In this video, we're going to talk about multicollinearity, which is another factor that may affect the statistical inference in linear regression. And we are going to also talk about different ways that you can eliminate it. You can fix the problem. We are going to use data file cinema in this video. So just to give you a general rule, if you want to have a clear, neat regression, as accurate as possible, you should target to have a high correlation between the dependent variable y and each one of your xi's. So high. This should, ideally go to 1. And as it gets closer to 1, you should expect a better regression, a more accurate statistical inference, right? So high correlation between yi and xi's, that would make the basically the coefficient of xi in the regression more significant if you have higher correlation between y and xi. But then you should be targeting a very, very low correlation between each one of these, each pair of xi and xj. So if you're dealing with a multiple regression, if you're running a multiple regression, the correlation between each one of the independent variable should be as close as possible, close to 0. If the correlation between xi's and xj, any pair of your independent variable, if the correlation is greater than 70%, and I'm talking about the absolute value of correlation. If the absolute value of correlation between any two independent variables is above 70%, that is called multicollinearity. So there is multicollinearity between xi and xj. There is multicollinearity in the model, which may affect, and that can affect, I'm not saying that it will affect, it can affect p-values. P-values that we use for checking the significance. So it can affect the p-values in a bad way, in a misleading way, that we don't want that to happen, all right? So so this is what happens. If you have multicollinearity, it can affect p-values. If you have p-values less than 5%, if they're significant, then there is no problem. Multicollinearity, even though it exists, it's not creating any problem. But if one of the p-values or both p-values for these two independent variables is, if one of these is less than 5%, is greater than 5%, greater than alpha, you should check the multicollinearity by removing each one of those separately, and again checking the p-values and see if the effect is a true effect on the p-value or not. But again, that is a little above the scope of this course. What we need to check is to basically check the correlation. If the correlation is above 70%, we say multicollinearity exists. How do we fix it? When you have multicollinearity, the easiest way to fix it is to just remove one of variables, one of the variables that is creating the multicollinearity. If you have multicollinearity and it's making p-values like significantly larger than it should be, then you should remove one of the variables. And I'm going to show you an example, and an extreme example of how multicollinearity can affect the p-values and how we should basically remove one of the variables. So that would be basically how to fix it. Remove one of variables, or sometimes you can aggregate, you can just multiply them and just come up with just one variable rather than two variables that are highly correlated to each other. All right, so I'm gonna open data file cinema. In this data file, I have three columns, three main columns. I have for a branch of cinema and for different days or different month of the year, I have, or for different periods, right, different weeks, for example, I have three variables. I have the dollar amount spent on online ads. Also, I have the number of online ads, right? And I have the number of tickets sold. So this is the sales, I mean, in terms of units of tickets sold. And I have number and dollar amount spent on online ad, with respect to online ads, all right? So as you can see, by definition, these two variables should be highly correlated, because as you increase the number of online ads, you should spend more on it, all right? So, and so this, by definition, they should be, logically speaking, they should have a high correlation. I'm just gonna check correlation between, check multicollinearity. So that would be by checking the correlation between column B and column C, or you can just pick the numbers. So if we just take that, it's going to give us almost perfect correlation between these two, which is problematic for regression. If you want to have both of these factors, both of these variables into your regression model, right? So this check multicollinearity is, so multicollinearity exists. All right, so it exists. Now we want to see if it creates any problem. It exists. I said it may or may not make your p-values showing up wrongly, like larger than they should be. So what I'm going to do now, I'm going to predict sales based on online ads. So I'm going to include both of them first. Both of these, both number and dollar amount on in my regression model, and try to explain tickets sold, try to predict this. So I'm going to run a model, data tab, data analysis, regression. So Y range will be tickets sold. X range will be dollars spent on online ad and number of online ads. So if I just include that, and I have labels, if I just put it in here, F7, and for now, no need for residual plots, nothing else. I just want to check the p-values. All right, so we know that multicollinearity exists. We just ran a regression using both of these highly correlated independent variable to predict tickets sold. Now, I'm not going to write down the equation. I'm not really interested in coefficients for now, but what I'm interested in right now is the p-values. So p-values are above, I mean, both of them are insignificant. Both of them are greater than 5%. Dollar amount is almost, is close to 5%, but still, both of them are large. And since I had multicollinearity exists, and p-values are now greater than 5%, so that is a red flag. Multicollinearity exists, p-values are greater than 5%. If p-values were not greater than 5%, we shouldn't really worry about multicollinearity. Multicollinearity sometimes exists, but it's not creating any problem. So in this case, I'm gonna check. So how do I fix multicollinearity? By just combining these two. You may, I mean, depending on the application, sometimes it's better to multiply, sometimes you just add them together. Um, it depends on the application. It depends on the case and scenario. But here, I'm just gonna remove one of them and take just one into the regression. So here I had a multiple regression. How do I know that these p-values doesn't make a lot of sense? Because I have my significance f almost 0, and I have a high r squared, a significantly large r squared. 92% is a great value for r squared, but still my p-values are showing up not significant, all right? So I'm just gonna run another model, this time with just one of these factors. So column D is good, my Y range, my X range, I'm just gonna use this time the dollar amount. So I just include column B, B1 to B25, and I'm gonna put it right after this one, F28. All right. So by removing the number of online ads, I'm not losing much in my R squared. R squared has decreased by 2% from 92 to, it was 92 and now is 91. So almost 1%. I lost 1% of my R squared. But the interesting point is this, the p-value now is almost 0. The p-value is now less than 5%. So that is now it's significant. Shows that they're not significant. Wrong conclusion. Wrong conclusion, because obviously from the R squared, from significance F, we see that there should be something that should explain this significance F, and we can't get it from the p-values. None of these factors are coming up as significant. But when you just run a simple regression, when you just remove one of these two and run another one, you get a model that is now a much better model. So you have a high R squared, you have a significance F that is 0, and you have a factor, an independent factor in your model that is absolutely significant.